All right, let's finish up this exam review. Last Thursday, we had gotten to question 13. You are performing a right-tailed test with a test statistic z equals 0.47. Find the p-value to 4 decimal places. So if it's a right-tailed test, I have to draw a picture. Right-tailed test, normal curve. So the center of the normal curve is 0. So z equals 0.47 is over there to the right of 0. And the p-value, since it's a right-tailed test, is the area under the curve to the right of 0.47. Now, if it were a left-tailed test, they would probably give you a negative z-value. It would be over on the left of 0, and you'd find the area under the curve to the left. It's 6 of one, half dozen of the other, because it just simply tells you what you put in to your normal CDF, lower upper limits. The mean and the standard deviation are 0 and 1 because this is a standard normal curve because you're talking about z values. Okay, so what is the p-value? The p-value is the area under the curve, so we're going to use a normal CDF. The lower limit, since this is right-tailed, the lower limit is the 0.47. What's the upper limit? 1 times e to the 99 with a mean of 0 and a standard deviation of 1. So let's go calculate that on our calculators. So our distributions are above the variables menu, correct? Second, variables. Normal is number 2. The lower limit was 0.47. The upper limit, we're going to make a really big number, 1 times 10 to the 99. And 0, 1 for the mean and standard deviation. So the p-value is 0.3192 to 4 decimal places. Be really careful. I graded papers yesterday, and the amount of round-off error I see is way beyond the skill level you should be at. Round-off is way back in elementary school. So read how many places they want you to round it off to. 3 or 4 decimal places is going to be typical for this entire test. Okay, so 0.3192 to 4 decimal places. All right, next problem. And I didn't say what would happen if this were a two-tailed test because my next problem is a two-tailed test. But if that were a two-tailed test in the previous problem, the easiest way to find the p-value in a two-tailed test is to take 1 minus the area in between. So you're going to be performing a hypothesis test, but you're going to have to find the p-value. You're performing a two-tailed test. So in this particular problem, it's a two-tailed test. On your exam, it might be left-tailed, right-tailed, or two-tailed. I don't know. But in this problem, it's two-tailed. With a sample size of 25, alpha is 0.2, your test statistic is 2.75. Do you fail to reject or reject the null hypothesis? So just like a normal curve, a t-curve, a student's t-curve, is symmetric. So if I'm doing a two-tailed test, I'm finding the area to the right of positive 2.75 and to the left of negative 2.75. So two-tailed test, I'm finding the area below negative 2.75 and above 2.75. They're symmetric, okay? And so the easiest way to do this, whether this is a t-test or a z-test, is to do what? The p-value, the total area under the curve is 1. So if I take away the area in between the negative 2.75 and 2.75, I should have the area in the two tails. So is that a TCDF? TCF, I think is how it's in your calculator, isn't it? Sorry about that. And what's our lower limit? Our lower limit's negative 2.75, our upper limit's 2.75, and the degrees of freedom, a t-test, they want the degrees of freedom. In a z-test, you would just put 0, 1, correct? Okay, so we're going to go to our calculator and do this calculation. All right, so 1 minus. Go to our distributions. The t distribution is number 6. The lower limit was what? Negative 2.75, because we're going to be finding the area in between and then subtracting that from 1, 2.75. Degrees of freedom, there were 25 in our sample, so the degrees of freedom is what, 24? Point 0.0111 to 4 decimal places. Does it tell me how many decimal places? No, it just wants me to reject or not reject. So I don't even have to type that in. So I got 0.01. I'm just going to round it off to a couple of decimal places because I need to compare, don't I? So I'm comparing to what? 0.2. So is 0.01 greater than or less than 0.2? So the p-value is less than alpha. What do you do? Reject. If the p-value is less than the set alpha, you reject the null hypothesis. All right. Any questions? Problem 15. Poverty in Alaska versus Hawaii. If we have 18 out of 320 families in Hawaii that were below poverty line, and if we random select 330 Alaska families, we find 35 families below the poverty line. At the 1% level of significance, so alpha's 0.01, do the data provide sufficient evidence to conclude a difference in the proportion of families below poverty line for Alaska and Hawaii? So what are the correct hypotheses? What are we looking for? Do data sufficient conclude a difference, a difference. So our alternative is going to be what? Not equal to, so the null is going to be equal. Okay, and what are we doing? What are we comparing? Are we comparing two means or two proportions? Two proportions. So P1 equal P2 or P1 does not equal P2. And you're going to pick the P1 and the P2 from the drop-down menu. Okay, so now what do we need to do? We need to go find a test statistic, correct? So we're comparing two proportions. So are we going to do a 2 proportion Z test? We're comparing 2 in a Z, it's a Z test because you're doing the normal approximation to the binomial. When you have proportions, that's a binomial distribution. Okay? So shall we go put this information in? So I'm just going to let P1 be Hawaii and P2 be Alaska. It really doesn't matter because you're looking at alternative hypothesis of not equal to. All right, so let's go to our calculator. And we're going to go stat test. And we're going to find a two proportion z-test. Is that number 6? Okay, so what information do I have here? Let's look at Hawaii. We have what, 18 out of 320? So 18 out of 320. And then Alaska was 35 out of how many? 330? Oops, it helps if you do it right. 35 out of 330. And we're going to be testing the alternative hypothesis of what, not equal to? So highlight that and then calculate. So the p-value, well, the z-statistic is negative 2.320. I think they tell me to do it to, they don't tell me. They don't tell me how many places to round off to. So I would round off to 4. That's a good, safe bet. So negative 2.3200. The p-value to 4 decimal places would be 0.0203. So let's go input that information. So my test statistic was negative 2.3200. My p-value was what? Thank you. So is that p-value greater than or less than the level of significance? Is it greater than? And I apologize again, every single one of the problems on my review is what? Reject? Or fail to reject. If the p is high, the null must fly. So what are we going to do? Are we going to fail to reject? So be sure you do your own review, just to make sure. Okay, so now I'm going to pick from a couple of drop downs. The correct conclusion would be, and the fact of the matter is, there isn't sufficient evidence to conclude. So one of the drop downs is there is not enough. So the evidence, the data that we have doesn't support the alternative. So there's not enough evidence to support that they're different. So there's not enough evidence to conclude that Alaska and Hawaii are different at a significance level of 1%. And then it asks us to find the confidence interval. So for a 2 proportion test, we're going to use 2 proportion z interval that will find the confidence interval for us. And they do say 99%, which would be correct. If I'm testing at a level of alpha equals 1%, then the confidence level would be 99%. So I'm going to go back to my calculator. Maybe. And I'm going to go to stat, tests, and do you find a 2 proportion z interval? B. And it should remember what I put in for the test. Does it? It does. And that confidence level I have there is correct, 0.99. So let's go calculate the confidence interval. So that those two numbers in parentheses are the lower limit on the interval and the upper limit on the interval. So the lower limit is negative 0.1046 and the upper limit's 0.00503. So that is the confidence interval of the difference in the two proportions. And they actually do give me the P1 minus P2. So I'm just going to put in those two fields the lower, which was what, negative 0.1046, and the upper was 0.0050 to 4 decimal places. All right, a couple of quick and easy problems. 16. Suppose the results indicate that the null hypothesis should not be rejected. Thus, it is possible that a type 2 error has been committed. Type 2 error, you fail to reject the null when it's false. Given the type of error made in this situation, what could researchers do to reduce the risk of this error? What's the only way to reduce a type 2 error? Only one way. What's that? Sample size. The only way to reduce the risk of a type 2 error. And a type 1 error, the probability of a type 1 error is alpha. So you choose that. You choose how willing you are to risk a type 1 error. A 2011 Gallup survey based on telephone and face-to-face interviews with 4,220 adults in China aged 15 and older suggests that 30% smoke regularly or occasionally. The following is also noted. One can say with 95% confidence that the maximum margin of sampling error is 2.2 percentage points. So which of the following statements is true based on the results of this survey? Well, if you have 30% and they give you a margin of error, they give you a confidence interval. So what's the confidence interval? Is it 30% minus 2.2 to what, 30% plus 2.2? So is that 27.8 to what, 32.2? Did I do that subtraction correctly in my head? Okay, so which one of those 5 statements is true? Well, this is not right. It doesn't say that. It says that as a matter of fact, that if we look at the population, we are 95% confident that it's somewhere in between the 27.8 and the 32.2. So actually, I just said it, didn't I? Is that what it says? It says that we're 95% confident that somewhere in between those two numbers is the true population proportion of Chinese people 15 years old and older that smoke. We are 95% confident that no, that's all right. If the sample size was larger, the margin of error would be larger as well. Well, that's definitely not true. Not true, not true, not true. Exactly. No, it's got to be the first one, doesn't it? Okay, question 18. We got to do a test. And this is our last test on the test. Nationally, patients who go to the emergency room wait an average of 4 hours to be admitted into the hospital. Do patients at rural hospitals have a higher waiting time? The 13 randomly selected patients who went to the emergency room at rural hospitals waited an average of 4.1 hours to be admitted into the hospital. The standard deviation for those 13 patients was 1.8 hours. What can be concluded at the alpha equals 0.05 level of significance? For this study, what type of test should you use? Now, it would help if you had the drop down. It would be a t-test, and how do you know that? Because it gives you a mean and it gives you a standard deviation of the sample. So it is a t-test. So it's a t-test for a population mean. Very good. Okay, so what is my null and my alternative hypotheses? So it is mu, right? Because we're talking about means. So what are we trying to show here? Do patients at rural hospitals have a higher waiting time than the population average? So it's greater than, and what's the population average? 4 hours. So this would be what? Equal 4? Okay, so now we're going to go calculate a t-statistic, correct? So let's go do that. We're going to run a t-test. Okay, so we're going to go stat tests. And our t-test is the second one, correct? Number 2. And then what are we going to be? We're going to be putting in stats, correct? They gave me the statistics. They didn't give me raw data. And mu sub 0 is what we're testing against. Is that the 4 hours? And how about our rural hospitals? Was their average weight 4.1? With a standard deviation of, what was their standard deviation? 1.8? And how many hospitals did we look at? Or patients, we looked at 13 patients. And we're doing a test, what, greater than a right-tailed test? Is the mu we calculate greater than 4? Okay, so the test statistic t to how many decimal places? 3 decimal places is 0.200. And the p-value is 0.4223 to 4 decimal places. They do ask me to round the t statistic off to 3 decimal places and the p-value off to 4. Okay, so our t statistics was well, we don't want that. Unless you want to do functions and modeling, I don't think you do. There you go. So 0.200, the p-value was what, 0.4223. So is that p-value greater than or less than alpha? It's greater than, so we are going to fail to reject. The p is high, the null must fly. All right, so what are we going to conclude here? Okay, it's not significantly, so that one's good. Not significantly. That one's out because it's not significant. The data we collected is not significant. All right, so what do you want to say? Waiting time. Nope, not equal. So it must be this one, huh? The data suggests that the population mean awaiting time to be admitted into the hospital from the emergency room for patients at rural hospitals is not significantly higher than 4 hours at alpha equals 0.05. So there is statistically insignificant evidence to conclude that the population mean waiting time to be admitted into the hospital from the emergency room for patients at rural hospitals is higher than 4 hours. All right, your last two problems. Woohoo! A 2011 survey by the Bureau of Labor Statistics reported that 91% of Americans have paid leave in January 2012. A random survey of 1,000 workers showed that 89% had paid leave. The resulting p-value is 0.0271, thus the null hypothesis is rejected. It is concluded that there has been a decrease in the proportion of people who have paid leave from 2011 to January 2012. What type of error is possible? What's the only type of error that's possible if you reject the null? And it's true. If you reject the null and it's true, that is a type 1 error. That's it. If you fail to reject when it's false, that's a type 2. Okay, last but not least. Now I did go check this morning, and this problem can be widest or it could be narrowest. So let's look at both cases. Otherwise, it's the same problem. Just saying. Which of the following would result in the widest confidence interval? Okay, so it might be helpful to remember that error bound of the mean thing. So the error bound of the mean is what? Your z sub alpha over 2 times what? Oh gosh, can I remember what it is? Yeah, I don't know. I can't remember what it is, but I do know that the z is in the numerator and the square root of n is in the denominator. So if you're looking at the widest interval, you want n to be the smallest. So if you're going widest, n needs to be the smallest because it's in the denominator of a fraction. Okay, so it's going to be between what? This one and this one. Okay, and then what? The z value is in the numerator, and the z is biggest when your confidence level is the largest. So z is biggest. I don't know if that's a good way of putting it mathematically. Biggest when what? Confidence level is the largest. So which one would it be? Would it be this one? Because that's where you've got the smallest n value and the largest confidence level. So where would it be the narrowest? The opposite? So what would that be? This one? When the confidence level is the smallest and the n is the smallest, would that do it for you? All right.